Okay, maybe do you remember that we took one differential equation which is in this form, and yeah, the equation which is in this form, it is called as a Legendre differential equation. And then we found the series solution of that, okay, using the power series method. The method what we called is called as power series method. Using that, we found the solution of Legendre's differential equation. Okay. And there are some few things like which is not there in your syllabus. Um, it actually, we can write the all the terms you have seen in between somewhere after comparing the coefficients and all. We were getting a r plus 2 is equal to like this. Okay, like if we find a2 will be in terms of a naught, a4 will be in terms of a2, but a2 in terms of a naught, like this. We can write. So all the even suffix terms we were writing in terms of a naught, and all the odd suffix terms we were writing in terms of a1, like a3 in terms of a1, like that we were doing. Okay, we can actually do the reverse also. We can actually write a1 in terms of a3, but since here we know something about a0 and a1 that they are not equal to 0 when we took the coefficient of x power minus 2 and x power minus 1. So we write like this. Okay, always we write the highest suffix terms in terms of lowest suffix terms. Okay, and actually, as I said, we can write AR in terms of AR plus 2 also. Okay. So if it is a nth degree polynomial, like if we have an x power n, then a3 we can write in terms of a5 we can write in terms of a7 using this formula what we have. We can do that also. Okay, and as I said, all those things are not there in your syllabus. So what I am trying to say is, we can write these u of x and v of x like the coefficients what are there here, a naught, they need not be in terms of a naught and a1 always. Maybe we can write in terms of an also. If we take this a naught into u of x, it is a polynomial, and that polynomial we can write in terms of an also. Now what we have is, like if that constant an is so chosen, we choose an such that y is equal to f of x, it becomes 1 when x is equal to 1. So such type of polynomials what we get, an into something will be there, right? Together it's a polynomial. So those polynomials are called as Legendre's polynomials. Okay, an into something will be there. Like we have a naught a1 into x power 1 plus a2 x square plus a3 x cube, etc. Okay, so we can write that polynomial what we get, we can write in terms of an into something also. Okay, so if we choose an such that that solution, it always becomes 1, y becomes 1 when x is 1, then that type of polynomials what we obtain, it's called as Legendre polynomial. It is denoted by Pn of x. Okay, that definition is not important for you. That Rodrigue's formula, there is a formula, based on this formula we have problems now. Okay, what is Rodrigue's formula? It's a formula for the Legendre polynomials Pn of x. Okay, we can prove it that it is in this form. Actually, we have P naught of x is something, P1 of x is something, P2 of x is something, etc. In general, for Pn of x, this is the formula. Okay, in some of the problems, yes, we need in particular P naught of x, P1 of x and all. Whenever we need those particular things, we can substitute in value 0 or 1 or 2, etc. and we can find. Okay, and the instead of remembering, if you can remember P naught of x, P1 of x, P2 x, etc. in separate also, if you can remember, it's fine. But otherwise, if you can remember this, then by substituting n value, you can find all those different polynomials of degree 0, 1, 2, 3, etc. Okay, and the formula is Pn of x is equal to 1 by 2 power n into n factorial d power n by dx power n of x square minus 1 whole power n. Okay, that means nth derivative of x square minus 1 whole power n. This is known as Rodrigue's formula. Now, what kind of problems do we have? First, what are we doing this? We actually need this P0, P1, P2, etc. Okay, so that we are obtaining first. This usually rarely they ask. Once long back they had asked actually. Okay, like this first problem what I have. But whether they ask this or not, we must know how to do it. Because for remaining problems, what we are doing in the first problem now, that will be used in the next problems. Okay, so whether directly they ask like this or not, we have to do it anyway. So we are learning it how to do. So what are they asking? Using Rodrigue's formula, obtain expressions for P naught of x, P1 of x, P2 of x, P3 of x, P4 of x. Okay, we can actually find P5, P6 also. Maximum they will ask usually till here. Hence express x square, x cube, x power 4 in terms of Legendre polynomials. Okay, Legendre polynomials are these like P0, P1, P2, P3, these what we have. These are Legendre polynomials. Okay, I mean these are the expressions for Legendre polynomials. So now finally they are asking us to represent x square, x cube, x power 4 and all those things in terms of Legendre polynomial. Okay, so we will start with Rodrigue's formula. What is Rodrigue's formula? It is Pn of x is equal to 1 by 2 power n into n factorial d power n by dx power n of x square minus 1 whole power n. Okay, this is the Rodrigue's formula which we have seen here just now. In the box what we have, the same formula I have written. Okay, and then what should we do? Because they are asking to find P0, P1 and all. So just let's substitute n is 0 and then 1, 2, 3, 4 etc. in the Rodrigue's formula. Okay, when we substitute n is 0, now just compare this first line and last line. I'm just taking n is 0 here. P n value is 0 now. P naught of x is 1 by 2 power 0, 0 factorial, d power 0 by dx power 0 of x square minus 1 whole power 0. Okay, what I have done is wherever n is there in Rodrigue's formula, I have taken 0. Okay, so you can see x square minus 1 whole power 0 is 1. Okay, and differentiation of, okay, it's not differentiation because d power 0 by dx power 0. That means we are not differentiating at all. Okay, 0 time we are differentiating. So we are not differentiating this term. D power 1 by dx power 1 means 1 time differentiation, but this is 0. That means we are not differentiating this term. So x square minus 1 whole power 0 is 1. 2 power 0 is 1. 0 factorial is 1. So P naught of x is 1. Okay, P naught of x is 1. It's easy to remember. Even while doing problems, if you find 1 anywhere, you can substitute P naught of x. Like if they are asking you to express any term in terms of Legendre polynomial, if you have 1, it's P naught of x. Okay. Now, yes, P naught of x is 1. Next, we are finding P1 of x. So 1 by 2 power n value is 1 now. 1 by 2 power 1, n factorial, so 1 factorial, d power 1 by dx power 1 of x square minus 1 whole power n value is 1, x square minus 1 whole power 1. Okay, that means one time differentiation of x square minus 1 and into this term. Now one time 1 by 2 power 1 is 2, 1 by 2. D by dx of this term is 2x. So 1 by 2 into 2x, it is x. Okay, P1 of x is x. P naught of x is 1. P1 of x is x. What do we feel? Now we feel maybe P2 of x is x square. Correct? We feel like that. Let's see what happens now. Now P2 of x is 1 by 2 power n value is 2. N factorial, that means 2 factorial, n is 2. D power n by dx power n, again I have taken n is 2, x square minus 1 whole power n is 2. Okay, again wherever n is there in Rodrigue's formula, we have taken 2 here. Now, x square minus 1 whole square is there. Carefully do this. Okay. A minus b whole square formula. And it is 2 times differentiation. You should take care of that also. Okay. So, this a minus b whole square expansion is a square, which is x power 4, plus b square, which is 1, minus 2ab, minus 2x square into 1. And then denominator here 2 square is 4, 2 factorial is 2. Now we have to differentiate this term twice. Okay, I think I have done twice directly and substituted. So one time when you differentiate, you will get 4x cube. Next time you will get 12x square. 1 on differentiation 0. Minus 2x square on differentiation. One time differentiation is minus 4x, next time is minus 4. Okay, 2 times differentiation. And here 4 is a common factor. You can cancel that 4 with the denominator 8 and you will get this 1 by 2 into 3x square minus 1. Okay, this is our P2 of x. Similarly, P3 of x is, see, wherever n is there in Rodrigue's formula, I have taken 3. Right, everywhere 2 power n, n factorial, d power n by dx power n, x square minus 1 whole power n. I am telling the original formula, and here wherever n I am saying, we have taken 3. Okay, I am saying n because it is, maybe you will remember the formula if we say that again and again. Okay, so this is the formula. Now a minus b whole cube expansion. Okay, a cube minus 3a square b plus 3ab square minus b square. Okay, b cube. Okay, a cube minus 3a square b plus 3ab square minus b cube. This formula, and then like 2 cube is 8 and 3 factorial is 6, and then 3 times differentiation now. So 3 times is x power 6. When you differentiate thrice, first time you will get 6x power 5. Next time you will get 30x power 4. Next time you will get 120x cube. Okay. Similarly, this also one time 12x cube, then 36x square, then 72x. This 3x square, when you differentiate twice, you can differentiate. Third time it becomes 0. After 2 times differentiation, it becomes a constant. Third time it's 0. Similarly, minus 1 is also 0. 3x square, it becomes 6x first time. Next time it is 6. Third time it is 0. Okay. So then take the common factor and simplify. Fine. Now we have d power 4 by, I mean p4 of x, 2 power 4, 4 factorial, n value is 4. D power 4 by dx power 4 of x square minus 1 whole power 4. Okay, I think P4 of x is the last one that we are finding. We are not continuing like this. This is the last one. Okay. Now we have that we have used in the beginning, right? X plus 1 whole power n expansion. Which topic did we use? Binomial expansion? Some problem, somewhere we have used it. I don't remember now. Okay, let me recall later. So it is binomial expansion. Okay. So first formula is like a plus b whole power n. In particular, you can take like a plus 1 whole power n also. Okay, but actually we have minus sign here. When we have minus sign in the expansion, alternatively we will have plus minus sign. Okay, because the minus 1 whole power, that cube, the minus 1 power will be one time even, next time odd, even, odd. Because of that, we will get alternatively plus or minus sign. What is the formula? A plus b whole power n. It is starting with a power n. Okay, a power n. So x square power 4, which is x power 8. Okay. Then minus, as I said, alternatively plus or minus sign, minus nc1. Okay, nc1 is 4c1, which is 4. Then a cube, the power of a will be 4 first, power of a will be n. Then a power n minus 1, a power n minus 2, power of a will go on decreasing, power of b will increase. First we will have b power 0. Here we will have b power 1, b square, b cube, etc. Okay. So it is x a power n, x square power 4, which is x power 8. Next, nc1. So 4c1, which is 4. Then a cube is x square whole cube, x power 6 into b is 1 here. Okay, next we will have 4c2. 4c2 is 6. Okay, and then a square, x square whole square is x power 4, b square is 1 square, which is 1. And then next we will have minus sign. Okay, 4c1 here, 4c2 here, 4c3 here, 4c3 value is also 4. And then a value is x square, and b cube is 1 cube, which is 1, and plus 4c4 value is 1, a power 0 is 1, b power 4, 1 power 4 is 1. Actually, this if you feel that tough to remember, anyway we have up to p4 of x, right? What you can do, x square minus 1 whole square into x square minus 1 whole square you can take. A minus b whole square expansion, then multiply term by term. That also you can do. Fine. But I told about the formula because if you are finding whole power 5, whole power 6 and all, better to know the formula. But anyway, in Rodrigue's formula, you will not go for too much higher order polynomials. Okay. So then differentiating 4 times, we get this answer. Okay. This you have to check. Differentiating 4 times, it's easy anyway. Okay. I will get confused if I keep on saying, I guess. So then take the common factor, possible common factors outside and simplify. And this will be your P4 of x. Now, after this, what they are asking? They are asking and hence express. That means after finding this, using these, hence, that means using these, express x square, x cube, x power 4 in terms of Legendre polynomial. Okay, we have to express these in terms of Legendre polynomial now. Till here, any doubts in this problem? Any doubts in this? Any doubts, guys? Okay, it is just substitution and simplification, right? Okay, now, and Rodrigue's formula, one problem is 100% it will come. No doubt at all. Rodrigue's formula, one problem will be there in exam. Now the thing is, express x square, x cube, x power 4 in terms of Legendre polynomial. Already we have 1 is p naught of x is p1 of x. Okay. We got in the beginning itself. You remember, I guess, right? Here we have p naught of x is 1, p1 of x is x. So that we may have to use later. So I have written here. Then they are actually asking from x square. So for finding x square, we will use that p2 of x expression what we got just now here. See what I have written in the box. P2 of x is 1 by 2 into 3x square minus 1. That we have to use. We have to start with that. Then we want to express x square in terms of polynomials. So just cross multiply, take every term to the other side, keep x square on one side. Okay, we want to express x square in terms of these polynomials. Then if we need any other polynomial p0 or p1, we will use later. Okay. So what am I doing? Cross multiply 2 into p2 of x is equal to 3x square minus 1. Then we want x square, remember. So you take minus 1 to the other side. Yes, minus 1 I have taken here. So 2p2 of x plus 1. Then we need x square. So cross multiply 3 comes to the, yes, what I have done here is we have to use all the possible Legendre polynomials. So wherever 1 is there, you write p naught of x. Don't keep 1 as it is. Even if you have any constant 1 or 5 or 3, we will represent it in terms of polynomial. Okay. So we have wherever 1 is there, p naught of x. Then cross multiply, 3 comes to the denominator. Okay, x square is first p naught of x term I have written. So 1 by 3 into p naught of x plus 2 by 3 into p2 of x. Done. So we have expressed x square in terms of Legendre polynomial. Okay, one thing is done. Next, for x cube, same procedure, you should consider p3 of x. P3 of expression, here we got 1 by 2 into 5x cube minus 3x. Yes, here you can see this is P3 of x expression. Okay. So in that expression, what do we have to do? So this 2, you cross multiply, it becomes 2 P3 of x. Okay. And then take minus 3 P1 of x to the right side. And then cross multiply, 5 comes to the denominator. Okay. So x cube is in terms of P1 of x and P3 of x. Now P4 of x. P4 of expression is this. We did, okay, by taking that a plus b whole power 4 expansion, we have got this answer. Now we need x power 4. So 8 into P4 of x. Then this minus 30 x square and plus 3 you take to the other side. Then cross multiply. Okay, and the other thing is, what is this x square? You should not leave it as it is. You should not have any polynomial in x. Okay, every term must contain Legendre polynomial. So what is x square? Substitute for x square. Okay, x square is 1 by 3 into p naught of x plus 2 by 3 into p2 of x. So in place of x square, we have substituted this. Minus 3, don't keep 3 as it is. That also we should include Legendre polynomial in that term also. So minus 3 is minus 3 into 1. 1 is p naught of x. Minus 3 will be there. Okay. We are not writing it just as minus 3, but minus 3 into p naught of x. So that every term contains Legendre polynomial. So x power 4 is cross multiply, that 35 comes to the denominator. So that's it. Okay, p naught of x terms. You can see 10 p naught of x minus 3 p naught of x together 7 p naught of x. 7 p naught of x by 35. When you cross multiply, you will get 35. So 1 by 5 p naught of x. Okay. So this is how. And similarly, this 20 p2 of x by 35. So simplify, you will get 4 by 7. This is about expressing x2, x square, x cube and x power 4 in terms of Legendre polynomials. This problem they may not ask, but you will use this in the next problem. You will get to know now. Okay, when you see the next problem, you will understand why do we need this. Any doubts now? Others? Mayank, are you here? Mayank, any doubts? Mayank, not there? So sad. Okay. Now, next problem. Yeah. This kind of problems are important. Okay. Express the following polynomials in terms of Legendre polynomials. Right? X cube plus x square plus x plus 1. We have to express in terms of Legendre polynomials. So we already know that P naught of x is 1, P1 of x is x. What you have to do is see x cube expression already you know here. Okay, this one. I don't know, maybe some of you have the ability to remember this kind of expressions. I don't have. Fine, like this kind of one and all. Like maybe if it is, there is no other way, because if there is no other formula directly, if someone gives this formula, maybe we will try to remember. But when there is something like Rodrigue's formula, I feel that better to remember that. But if you can remember, also, what I say is exam point of view, you should write these things first. P naught of x, P1 of x and all you write. If you feel remembering these things is also tough, like if you feel P0, P1 you can remember, but P3, P4 and all is tough. If you feel, you can see that P3 of x is this, this is expression for P3 of x, right? And this is the expression for P4 of x. If you feel it is tough to remember some 4-5 expressions like this, what do you have to do? For every problem, you have to start with Rodrigue's formula and then you have to do all these things, substituting in 0, 1, 2, etc. that you have to do. Okay. So if you say that no, we can remember these things, remember P0, P1, etc. Okay. Directly don't write what is x square, x cube and all. You should write the expression for this P0, P1, P2 of x, P3 of x. P4 is not required here because it is a polynomial of order 3, degree 3. Okay. So P3 is enough. X cube is there. So P3 is enough. So what is x square? Like using P2 of x expression, just now we have derived what is x square. X square is this. Okay. It is just cross multiplying, taking the terms to the other side and rearranging the terms. We get x square is this. And similarly, P3 of x expression, if you use, you will get x cube expression. Using these expressions and x is P1 of x and the constant one is P0 of x, correct? So substitute all these in that expression what they have given. Polynomial, given polynomial, we can take it as some f of x and substitute for x cube, x square, x and 1. There will be several terms containing P1 of x, P0 of x and all that. Simplify, add them, subtract them, whatever you can do that. Simplify, final answer is this. Okay. So whatever polynomial they have given, that can be expressed like this. Say in this problem, x cube expression is this. 2 by 5 P3 of x plus 3 by 5 P1 of x. X square expression is this 1 by 3 P0 of x plus 2 by 3 P2 of x. X is P1 of x, 1 is P0 of x. So P1 of x terms, there are two terms. So 3 by 5 plus 1, okay, add them, you will get 8 by 5, 8 by 5 P1 of x. Similarly, 1 by 3 P0 of x plus P0 of x together 4 by 3 P0 of x. There is only one term containing P3 of x, so written as it is. P2 of x term only one is there, written as it is. Okay, so this is our answer at the end. And then second one you can try later. We have a similar problem here, again the second one. If x cube plus 2x square minus x plus 1. Okay, again we have till x cube. So it can be expressed in terms of like all these terms we can express in terms of P0 of x, P1 of x, P2 of x and P3 of x, right? These four are enough. P4 of x is not required because the degree is 3 here. So it will be definitely something into P0 of x, some constant into P0 of x. Maybe sometimes it is 0, that's fine. Okay. Some constant into P0 of x plus some constant b into P1 of x plus some constant c into P2 of x plus d into P3 of x. Obviously, P4, P5 and all will not be there here. So, find the values of a, b, c, d. What do we have to do? We have to do it exactly similar to the previous problem now. So given function is x cube f of x is equal to x cube plus 2x square minus x plus 1. Okay, now we have to substitute for x cube. Anyway, as I said, first you should write like this. We know that, write this. We know that p naught of x is 1 and all this line you have to write for every problem. Okay, and after writing this, if you don't remember x square, x cube expression, cross multiply and you do it there itself. It's fine. If you already remember this, you can directly write this implies, okay, you can write like this. If you can remember the formula, otherwise you just take the terms to the other side. Anyway, take one step or two steps, or you can just do in your mind and you can write this, okay. Then see x cube is this term plus 2x square is there. 2 into x square expression is this minus x. So minus x is p1 of x plus 1 is p naught of x. Okay. Now it is just adding and simplifying. So 2 by 5 into p3 of x. Then p2 of x term here. 2 into 2 by 3 which is 4 by 3 p2 of x. 3 by 5 p1 of x minus p1 of x. Together it is minus 2 by 5 p1 of x. And then 2 by 3 p naught of x plus p naught of x, together 5 by 3 p naught of x. So now if you compare this equation 2 with equation 1, you can say what is a value. Something into p naught of x, right? A is 2 by 5. B is minus 2 by 5. B into p1 of x. So B is minus 2 by 5. And C is 4 by 3. D is, which is D? This one, P3 of x. D into P3 of x, D is 2 by 5. Okay. So A into P naught of x, A is 5 by 3, B is minus 2 by 5, C is 4 by 3, D is 2 by 5. This is about finding the values of A, B, C, D. They can give any polynomial here. Maybe they will give some 3x cube plus 7x minus 8. Just substitute like how we did now. Substitute expressions for x cube, x square and all that. Simplify. Okay. These steps are not at all tough. Only thing is just remembering these things is important. Remembering these expressions for P0, P1, P2 and all that. And that is important. Or again, don't have to worry too much. If you feel that, okay, who will remember? Go for Rodrigue's formula, derive the expressions and then do. Okay. So this is how you have to do the problems on Rodrigue's formula. Any doubts now? Any doubts? Mayank, any doubts? Okay. Mayank will not answer. Now, take this problem and do. I will show you the expression. First, just write this expression now. 4x cube minus 2x square minus 3x plus 8. This expression you write, problem 3. Okay, this one, 4x cube minus 2x square minus 3x plus 8. Write this. Formula I will show you now. Have you all written? 4x cube minus 2x square minus 3x plus 8. Hope you have written. Shall I go back to the next page? I mean the previous page. Yeah, here are the expressions. Use these expressions now. Use these expressions and substitute there. In what problem I gave? Substitute there. X square is this, x cube is this, x is p1 of x, 1 is p naught of x. Okay, substitute now. Guys, are you doing? You want me to show the expression again? The problem I had asked is this. 4x cube minus 2x square minus 3x plus 8. This is the expression I have given. This is the problem. Okay. And you have to use these formulae now. These are the expressions required for you now. Written, substitute and simplify. Okay. 8 by 5 P3, 4 by 3 P2, minus 3 by 5 P1 plus 22 by 3 P0. And Shweta also got the same answer. Okay. Nikita, is it same? You have got minus 4 by 3. Okay, Nikita and Shweta both have got minus 4 by 3. Minus 3 by 5, and is it minus 22 and one had plus 22 by 3 last term? Neha plus 22, Nikita minus 22. Shweta, is it plus or minus?
Plus, ma'am.
Plus 22 by 3?
Yes, ma'am.
Okay. So Nikita, your plus 4 by 3 may be wrong. They have got minus 4 by 3, check. And Nikita, is this minus 22 by 3 correct? Please check.
Ma'am, it's plus 22 only.
Plus 22? Okay. Pavan, which is correct? Plus 22 by 3, Pavan? Okay, Namrata plus 22 by 3, minus 4 by 3, fine. Okay. Fine. Okay, you have messaged here, fine. Okay, once I'll check whether I was correct. My answer. If I'm wrong, fine. Because all of you are right. Is it somewhere near to your answer? Same, na? I guess it's same. Or maybe. Okay. So fine. So this is about Legendre polynomial. There is a little small difference. There is a little different type of problem on Legendre polynomial that I will do later. Okay, I didn't get proper problems on that. I'll do later. That's fine. We will do later. So this is mainly this kind of problems what we did today. That's very important, like giving a polynomial and express in terms of Legendre polynomial. Okay, so that's it for the day. Any doubts you can ask me. Any doubts now? No doubts? Okay, then give the attendance.